Welcome to SanfordFlipMath. This is Algebra 2. We have been solving systems for a bit, and we're going to wrap up solving systems kinda by solving 3x3 systems. What I mean by that is really we're going to be solving stuff like this, XYZ, XYZ or ABC. I want to pop back just to remind you of the basic concept of solving by elimination, because that's the method we're going to use for solving 3x3. And I just want to remind you the basic idea is match up your x's, match up your y's, match up the equal signs, match up the 2's. It doesn't have to actually be in standard form like these are, but that's typically how we see them. And so basically the idea, probably said basically about 100 times, we want to add equations to have a variable disappear. So this one's already magically set up. This one's from the previous video that we did. But the idea is negative y plus y add up to 0. I have 2x equals 4 then, and so x is 2. Oh, that I need an equal sign, sorry. And to find what y is, we just substitute that back in. So which equation do you need? It doesn't matter, just pick one. This is a good one. So x is 2, so 2 plus y equals 2. Subtract 2 from both sides, y equals 0. Here's the solution, 2, 0. Okay. None of that was new. In fact, I did that exact same example to start elimination last time. So what is new is 3x3, which means 3 equations, 3 variables. If you're trying to solve for 3 variables, you need 3 equations. If you're trying to solve for four variables, you need 4 equations. However many variables you're solving for, that's how many equations you need. So I'm solving for x, y, and z, so I need 3 equations. And the concept here is the same concept. We're going to add 2 equations together in such a way to make variables add up to 0. Okay. So what we need to do is target one variable. So you need to pick one that you think you can get rid of. I'm going to say easily, or the easier one to get rid of. So just pick one, it doesn't really matter. And what we're going to do is pick 2 equations. Okay, so we're going to focus on 2 equations, eliminate one variable, pick 2 equations, eliminate the same variable, and then, and not the same 2 equations. And then you take the results from those. Okay, so you pick 2 equations, you eliminate a variable, you're going to have an equation. Pick 2 equations, 2 other equations, eliminate the same variable, you're going to have another equation. So then you're going to solve that system any way you want, usually elimination, and then you can start substituting back. Okay, so what does all that mean? Find other variables, I guess is what I want to say, or other values of the variable. Okay, so that's kind of the quick set of steps. So let's do it. Okay, so you might start with the different set of variable, or eliminating a different variable. As I said, it doesn't matter. And so we're going to pick 2 equations. I think what I'll do is take the first 2 equations and we're going to eliminate x. So in order to eliminate x, I like this top equation. It looks pretty good. And then what I'm going to do is take the bottom equation, or not the bottom equation, that second equation, and I'm going to multiply it by -4 on both sides. So the reason I'm doing that is so that I end up with 4x and -4x. Okay, and so the x's are going to cancel out. Okay, I have to multiply every single term by -4. So this is going to be plus 16y. This is going to be plus 8z equals 8. Okay, so then we'll add those 2 together. Okay, so -4x, positive 4x are nothing. This is 17y equals 13. Oh, I'm sorry, plus 13z equals -1. So that's one equation. Notice I have two variables. So I need another equation with those same two variables. So what I'm going to do now, I'm going to erase this stuff off the middle equation. What I'm going to do now is I can't use the same two equations. Well, I have to use at least one of the same two equations. I mean, I only have three to pick from. Okay, so what I'm going to do next is maybe I'll use that middle one and the bottom one. Now, I like the middle one because that front x is just x. So it makes it easier when I can multiply by anything and make what I want. So again, I need to eliminate the same variable. Okay, so this is me working on the bottom equation. And I'm going to work with that middle equation, and again, I'm trying to eliminate x. So this time I'm going to multiply by -2 on both sides. Again, I have to distribute this all the way across everything. So this is going to be -2x plus 8y. Okay, so I'm doing this, then that's going to be plus 4z equals 4. Okay, again, we're going to combine these. Now, again, the goal was to eliminate x. Again, it doesn't have to be x. It just needs to be the same variable for both. So there are going to be times when maybe you're not going to use x. Maybe you're going to try and get rid of y. Maybe you're going to try and get rid of b, whatever. Okay. So what we have now are these green equations. I'm going to pull them together and make a new system out of them. Okay. So I have 17y plus 13z equals -1. 11y plus 2z equals 25. Now this becomes a problem like we've done before. Okay, I have two equations, two unknowns. I need to solve the system. You can use whatever method you want now. It's just probably what you're going to end up using is elimination again. Okay, so these two don't come out quite so nicely. It's not like I can multiply 2 times a nice number and get 13. I mean, yeah, I can multiply it by 6.5, but ew. And if you want to do that, you can do that. If you want to multiply the bottom equation by -6.5, that'll get the z's to add up to 0. Okay, so I mean, that'll work. Generally, we don't do that when we come to this kind of a situation. Usually what we do is multiply the top by one thing and the bottom by another. So what do you want to use? You might pick differently than I pick. It's entirely up to you. I guess what I'm going to do is try and match up those z's. So I'm going to multiply the top equation. Let's do -2, and the bottom equation we'll do by 13. So the idea here is I'm going to get this to be a -26 and this to be a +26. Then they will add up to 0. Okay, so here we go. -34y minus 26z equals 2. And on the bottom one, 143y plus 26z equals whatever 13 times 25 is, which is 325. Yeah, I did this one earlier. That's cheating. Okay, so combine these. Goodbye to you. Actually, let me do that in another color so you can see how that started out. Okay, so goodbye to that. Then we're going to add these two, the -34y plus the 143y, which is 109y. Mr. Sanford, this is ridiculous. Yeah, it is. 327. We're almost. That's not a 7. Okay, let's try that again. 327. Okay, and sorry, I'll scroll that back down. So if you need to see the rest of that, divided by 109. And y equals 3. Awesome. So what? Okay, so we've done the hard part. The rest of this is now substitute back in and find the other values, the other variables. Okay, so this is again the hard part. Okay, so let's take this 3. This is a y value. I need to put this in to one equation that has 2 variables, y and something else. Okay, so I'm going to go back to one of these. It doesn't matter which one of these you pick, provided they're all, handled correctly. So we're just going to pick one, and I guess I'll put the y into, I guess this one. So 11y. Okay, so 11y plus 2z equals 25. And I'm just picking this one because it'll be easier to divide by 2 than to divide by something else. Okay, so 33. So when you're doing this, be strategic. Okay, so subtract 33 from both sides. Okay, so we have z. So I have y, I have z. Now I need to go back to an equation that had x in it. Well, all the equations with x in it were the very original equations. Okay, and again, I'm going to pick what I think is the easiest equation to solve for x, and I think it's that one. So x minus 4y minus 2z equals -2. Okay, sorry, just trying to see the equation. All right, so I'm going to substitute the stuff I know. Okay, I don't know x, so that's coming along. Okay, and just for the record, if you haven't caught on, my z's have lines through them. My 2's do not. Okay, so just be careful. That's why I put the line through it, and in French, that's what they do. I think that's true in Spanish. I'm not sure, but lots of math people do 2's like that or 2's like that. That is a z. Okay. All right, back to this. So again, y was 3, and z is -4. Okay, so x minus 12 plus 8 equals -2. Now what we have is an order triple, and yes, they are in alphabetical order. They're in order x, y, z. Generally, we put these in alphabetical order. So x is 2, y is 3, and z is -4. Okay. Remember that this is the solution to a system. Solution to a system is supposed to make all of the equations true. So if you were going to check this, you would put these 3 numbers into all 3 equations, and it should make all 3 of them true. Okay. Now, the examples for this are obviously very long. I would like to do one more just to make sure that you know what you're doing, and some weirdness can happen. So here we go, one more. Again, if you know how to hit pause, rewind, play it again, whatever you need. Okay, so we're going to do this one. I'm going to kind of move along. I don't have to talk quite so much because we've done one. I do want to start out by saying this one looks weird. I'm going to recommend that if terms are missing, you write them. So like for instance, I'm going to rewrite this system. Now most of this is the same. So I mean, if you were doing this and you just wanted to like adjust the one equation, you're certainly welcome to do that. But there is no z here, so I'm going to write plus 0z. Is that required? No. Do I think it's smart? Yes. Okay, so this is the system. I want to pick 2 equations to eliminate the same variable. Well, I already have z eliminated here. So maybe I should pick these 2 and eliminate the z. Because the cool thing about that is that I already have this one done, right? So I'm going to do that. Okay, so here we go. I'm just going to take the top equation and the bottom equation, and I'm going to rewrite them. I know some of you are looking at it right now saying, I can see that those z's are going to cancel out already. Okay, but for the sake of clarity for the people who can't look past this middle equation, I'm going to rewrite this. Okay. So if this is cheesing you off, then feel free to fast forward. Okay, all right, well, let's add them up. Okay, so my goal was to eliminate the z's. They are gone. 2x plus a negative 2x, that went away too. 3y plus, So the whole left side of this is 0. I still need to write something over here. Okay, when I add these guys together, that's 15. We've seen this kind of thing happen before. So if the variable disappears, there are two possibilities. Either it's no solution or everything is a solution, or there are an infinite number of solutions. Remember that the choice is this. If what you see is false, like 0 is equal to 15, no it's not, then it's no solution. So this guy was no solution. If what you see is true, like if it came out 3 equals 3 or 0 equals 0, then it would be many solutions. Okay, so we're done with this system. All right, so again, the idea is, I listed my steps here. Pick two equations, eliminate one variable. Pick two other equations. One of them can obviously be the same. It's going to have to be. Eliminate a variable. Now that you have two equations with two variables, now you can solve that system like we have before. Eliminate another variable, do substitution method, whatever. Once you narrow it down to one equation, one variable, solve for that variable, and then start substituting back to find the other two variables. Okay, that's the recap. Okay, all right, I'm leaving it at that. We're at 17 minutes, so thank you so much for watching. This is SanfordFlipMath. Bye.